There's a lot of videos online showing people making aerosol cans refillable by adding one of these valves. I wanted to see if it actually worked. I bought some Schrader valves on eBay. These are the kind of valves you have on a thick wall tire, like for a tractor. You can use a tool to remove this inner piece, which is called the stem, I believe, and that's the part of the valve which actually slides and has the sealing action. There's also a cap which you just unscrew by hand, which I believe prevents leaks. I was lucky enough to borrow a friend's lathe, and I was able to turn these down to 1/4 inch. It happened to be an imperial lathe and an imperial micrometer. If it was metric, I would have used 6mm. The diameter is not critical. We weren't able to turn down the entire length. Past the O-ring, it actually increases in diameter a little. That's because we had to use light clamping pressure from the 3-jaw chuck and tailstock support, since the part sticks out more than twice its diameter. Now, the tool post just wasn't fine enough to get into the tailstock, but it doesn't matter because we can just cut that off. So I used a hacksaw to remove that. The O-ring groove is actually very helpful for aligning the hacksaw, and that made the job a little bit easier. You can see one there. I didn't bother to clean the ends up too much. I did very quickly pass them over a file, but I wasn't that bothered about how they look since they're going to be inside a can. So there's an empty air duster can. I drilled a hole in the bottom. This wasn't particularly even, but I did use a file just to remove any sharp burrs. I then used a hot plate and soldering iron to wet the flange. I also put solder on the can, and I was able to solder it in place. This is possible even with a relatively small soldering iron, but the hot plate definitely helps because of the thermal mass of the valve. Oh dear. It turns out that the dome of the can is not quite tall enough, and so there's a bit sticking out. Now, you might say I can just file that off. However, once we put a cap on, particularly these plastic ones, it increases the height considerably. And that's far too annoying to live with. I designed a little sketch just based on the measurements, and this is just a method of holding the valve tool and adding a little bit of height to the can rim. I started in FreeCAD. I went to the part design workbench and I designed this sketch. You can see the dimensions there. I made that quite a tight fit on both the can and the tool holder. I then used the part workbench to create a tube primitive, and I then used the part design to make this kind of channel section. There's the dimensions if you want to copy this. In order to make the kind of grabbing flexible section, I went to the draft workbench, then I used a polar array to create some copies of that. I then used a Boolean operation in the part design workbench to subtract those shapes. I then made a Boolean union to create the finished design. You can then export that as an STL file and send that off to be 3D printed. Here's the finished part. I'm very happy with the way it turned out. The can was a very tight fit, but it did indeed fit in. I don't really need the valve tool on there all the time. It just looks nice to have the kind of plastic section do two things at once. I was quite impressed with this. Even after a week, it didn't leak. Some people will question the value of doing this because invertible air dusters aren't that expensive, but they are a resource and there's really no reason to create waste. It may be possible to fill them by the top mechanism of the can, like how it was originally filled, but I don't know what you would need to accomplish that. And this method is pretty easy, minus the lathe operations. Thank you all very much for watching, and goodbye.